Looking at this pie chart here provided by the Commonwealth of Australia, you can see that the three main reasons for tsunamis are earthquakes, landslides, and volcanic eruptions. When pieces of rock and earth move underwater or tectonic plates collide, an upward jolt is caused, as you saw in the animation provided by the BBC, and the water is displaced. This is an underwater earthquake. The water then forms large waves that move out and away from where the earthquake happened. This information was provided by the Commonwealth of Australia and the Province of British Columbia. The red dots on this map created by the California Institute of Technology here shows the locations of different earthquakes that happened previously. It is obvious that the dots form the distinct shapes of the Earth's tectonic plates. This is because earthquakes are caused by colliding plates. The white square here is where the earthquake that caused the Boxing Day tsunami happened. The two plates that collided here were the Australian plate and the Eurasian plate. According to the California Institute of Technology, scientists were surprised by the large magnitude of the earthquake, because while they knew that earthquakes frequent here, they didn't know that they could be that big. After doing some research, they found that it was due to the deformation of the Earth's crust. According to National Geographic, Indonesia is also located on the Ring of Fire, as you can see on this map provided by the World Atlas, making it even more prone to accidents. The Ring of Fire is a horseshoe-shaped area about 40,000 kilometers long where disasters frequent. According to the BBC, the earthquake caused by the collision of the Australian and Eurasian plate had a magnitude of over 9. Far out in the ocean, the waves were less than a meter high. The waves traveled at a high speed of around 800 kilometers per hour. By the time the wave reached the shore, the water had gathered together to create waves up to 20 meters tall. This picture provided by Jafar is of a wave hitting a mosque in Banda Aceh. According to the BCOM, the Boxing Day tsunami caused the death of 275,000 people. $9.9 billion was lost, and 141,000 houses were destroyed. This picture was provided by Remling. 600,000 people in Banda Aceh lost their livelihoods, including everyone involved in fishery and 30% of those involved in agriculture. As you can see in this picture provided by Chu, many farms were flooded and many fishes have died. 1,200 kilometers of the Earth's crust shifted under the Indian Ocean. The energy released by the earthquake was equal to more than 23,000 Hiroshima bombs. In Banda Aceh, waves reached the height of 20 meters. Also in Aceh, 3 kilometers of debris and salt water was carried on land by the waves. The retreating waves eroded entire shores. This is a picture of Thailand's coastline before and after the tsunami hit provided by the BBC. The picture on the left is before the tsunami hit, and the picture on the right is after. The waves traveled at very high speeds. Within the first 10 minutes of the underwater earthquake, waves hit Nicobar and Andaman Islands. Banda Aceh was hit within the next 10. Within 2 hours, the waves hit Thailand and Sri Lanka. This is a picture of the wave hitting the coast of Thailand provided by Bell. The east coast of India was hit soon after. Over 1,000 German and Swedish tourists were killed. This is a picture of a map depicting the places impacted by the Boxing Day tsunami, provided by the BBC. As stated by Lacasse, the buildings closer to the coastal areas were more affected, like the buildings in this picture provided to us by Riley. The waves bring in debris that clash against the buildings. They also cause damage that can only be caused mainly by water, such as erosion and buoyancy. According to Webster, the two forces that are put upon a building during a tsunami are shearing, where the top half of the building is being pushed one way and the bottom half is going the other way, sort of like sliding, and bending. The tall waves of the tsunami will cause the top half of a skyscraper to bend.
The first solution is to build the skyscraper diagonally instead of facing the shoreline, so that the water will direct itself around the building wall. This is called streamlining, and it lets the water pass through and around the skyscraper, which would reduce the area of the pressure pressed against the building. If the tsunami runs straight to the building wall, there will be more pressure pressed against a wider area, which would make it easier for the building to collapse. If the building is rotated like building B, there will still be a strong force that hits the building, but the surface area will be smaller than building A, which would make it less likely for the building to collapse. The second solution is to use heavy concrete for the lower floors to make the skyscraper more stable. The reason why concrete is needed for our skyscraper is because concrete can recover quickly from water and is waterproof. According to the IMS Consulting Service, it can remain very strong in water and can survive in earthquakes, hurricanes, and tsunamis. They are very strong and can last very long. Concrete will be needed to defend the skyscraper, or the structure might fall and the tsunami will take it down very easily. Concrete will be appropriate for low-income countries like Indonesia because it is cheaper than steel, aluminum, cast iron, and reinforced concrete. It is also a lot lighter than steel and cast iron, which would make it easier to build with. It is also very strong in compression. The third solution is to have an open area at the bottom floors so that the water can just rush through the skyscraper. We will include pillars on the bottom 20 meters of the skyscraper to support it. It should not be an open wall. If the skyscraper is secured with walls, it will take up a lot of frictional area, as said in the first solution. This will make the tsunami attack the skyscraper with more water pressure, which would make the wall bend, collapse, and fall. If we use pillars, it will have less area for the water to hit, which would create less friction and less drag for the tsunami, which can let the water pass through and around the pillars. According to the Balkan Council of Mosques, the tallest tsunami in Banda Aceh was approximately 20 meters high, which is around 5 to 6 floors. These pillars will be 20 meters high, so that it would be difficult for the tsunami wave to reach the higher floors where the people will evacuate to. The last solution is to brace the buildings. The earthquake before the tsunami will shake the skyscraper. Bracing the buildings will let the structure of the skyscraper become stiffer. It is when we have cross-section structures around the building to support it. It will transfer the shearing force from the building to the ground. We will also be using shear walls that are made out of concrete and are used to support the walls. The bracing techniques will help the skyscraper remain stable. The S waves, the shear waves, will shake the floor from left to right and can weaken a lot of building structures. However, if we include bracings, we can keep the skyscraper in shape. These solutions will all be combined together for the first time and was never done before in other countries. With our skyscraper, there will be less deaths and injuries in case of a tsunami. Our skyscraper will include a lot of units inside the building, so it will be safe, relaxing, a clean space for citizens and families to evacuate. There will be a less chance of inhabitants getting sick in our skyscraper than having to face a tsunami. This skyscraper will help the social and health problems in Banda Aceh, Indonesia, because our steady and stable skyscraper will reduce injuries and deaths. It will be a very safe place for people to interact with each other. With our skyscraper, we will not lose as much people as we normally would with a tsunami. With the less amount of deaths and more people safely evacuated in the skyscraper, there will be less money spent on the search of the missing or dead people. We believe that taking action before a tsunami is better than cleaning up the mess after the tsunami occurs. The Sky High project will provide the best quality skyscraper that all people in Banda Aceh can go to.